Okie doker. Time to continue. 1 hour. Oh, fucking glasses. Okay. So, the compiler will see this place is receiving something of a given type. It is not actually, or it's receiving something of some type, but it needs this type. So the input for something is this, but it's actually receiving a this. It needs a float, but it's getting an int. Ooh, we have to convert this integer value into a float, or at least try to. A character to an integer to a character, etc. So, it has to somehow convert those values to values that are usable, or the initial value into the target value that's usable, so like 3 to 3.0, or 3.0 to 3, or 3 to whatever the character for 3 is, like 65 to lower or to uppercase A, something like that. And then whatever it would be, 98 or something like that for lowercase. And then, so once it finds that value, then we actually have to convert the binary from the value represented within the integer into the binary that is needed to represent the same value, or the converted value, in the float. So we have this integer value 4, and it is represented by binary blah 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 whatever the fuck 100, and then we have to find out. Okay, well, we need to convert it to a value. What is it? Okay, it's 4.0, so we need to point out. Okay, what represents that in binary? Well, it probably isn't 100. It's probably something else. So we have to have some sort of ow, fucking god. Oh. Of course, I'm sitting in a fucking wooden rocking chair with damn, with ridges and shit on the side. Oh, I carelessly pushed my elbow back into it. Oh my god. Okay, good. So we need to have some sort of library of conversions, some sort of known algorithms or whatever to convert to, one, identify the value that's needed, and identify how to represent that in binary. In the target data type. Okay? Collection of conversion rules called the standard conversions. Say how the fundamental types and some compound types convert to other types in the same group. 14 different ones. Shit. 5 categories. Numeric promotions. Small to big. Oh. Small integral types to integers or unsigned int. And a float to double. Oh, so like what? An int 8 to an int? A uint 8 to an unsigned int? So from 1 byte to 4? Or 8? Out of 8 bits to more? And then from a float to getting something with more memory? Double? Conversions. Conversions that aren't promotions. Meaning like an int to a float, a double to an int. Conversions that add or remove const or volatile. So if we pass in const something, and so maybe multiple of these are done. It seems like multiple of these have to be done. So if we did something that removed const and it was from an int to a float, we would have a numeric promotion and, not an int to a float, but a something to an int, or from a float to a double. It went from a const float to just a double. If we're passing it in the value itself, seems like these are more attributes of the variables, though. I can't remember volatile, but there's something in there about volatile. Thought it was like something about accessing the actual piece of the information, or that it's more subject to change for some reason. Like it's temporary, or I can't remember. Can't put my finger on it. Learned it in like the very, very, very beginning, or heard about it in the very, very, very beginning. it seems like qualification conversions are not changing the value, but changing the variable. Or changing... I guess that's all it is, yeah. So like if we're going from I mean, in this case, a const float to a non-const float, it's simply, okay, update the values accordingly, and just remove that. Or does it even need to remove that? It just passes the value, and then that's it. This variable's const. The one that's receiving it is not const. Value categories? I've never heard of that. I values and R values. Imaginary and real? I don't know. Irrational and rational? No. It says just float versus int. From null pointer to pointer types. Or pointer types to other pointer types. In pointer types, I think those are just pointers to different data types. So it's not, it's called a pointer type, but it's really a pointer to this type. But maybe there are other attributes of a pointer of a given type, or a pointer that points to a given data type, that distinguishes it from another one. Maybe they can do certain things by default or can't. Int to a float, numeric conversions. There needs to be a 4 here. The numeric conversions category. So for the compiler, for the compiler to perform it. Oh. You need to apply the int to float numeric conversion rules. Conversions and promotions, yeah, this is probably not mega common. I mean, maybe, because if you're initializing something with a const value, could be. Don't know. Don't know. So would this be like you're pointing to something and then you say, no, you're pointing to something else that's a different type, and that's the conversion? Because at a deeper level they're different somehow? Maybe. Seems like these would be the most. Like the parameters of a function are in float, but then like if somebody's located, if a guy's located at 7.2, 4.8, negative 32.7 in the world, and then someone uses, this guy uses an ability, push, and it pushes someone 3 units in this direction. Well, we're applying 3 in integer to this other value. So now we have to convert from an int to a float in order to do float addition. And it's probably common because we have things that apply specific amounts. Like I have a bucket with a float number of apples. It's got 4.3 apples because there's a third of an apple, a little bit of shavings and shit, little corners. Someone adds 2 apples to it. Well, we gotta add it. Can't just, like, what do I write a separate function to add it? Conversion rules are pretty damn helpful. Okay. Full list. Value transformation. Oh, and it's L and R. L and R. Left and right. What is this, like fucking... not valence. Chirality in chemistry or something? An array to... Oh, because an array is apparently a pointer to the first. I thought it was the first array element, but maybe not. Okay, so there's arrays and pointers. Function pointer. Pointer to where a function is in memory, because it needs to be in memory somewhere, I guess. Maybe? Does it? I didn't think that, I mean, I know that function pointers are a thing, but I didn't think that a function pointer, like that a function was an object or something that could be pointed to, because I thought that they weren't stored. Like, nobody talks about initializing or storing a function somewhere. We just say, yo, it's located within a file that's executed. Or is it, I mean, maybe it is copied somewhere deeper down? I don't know. Okay. Temporary materialization converts a value to a temporary object. Floating point promotions, integral promotions, integral conversions. Oh, so like an unsigned int to an assigned int or something? Like an 8 to an 8, 16 to a 16? I guess there are other types of floats. Integral floating. These are numeric, makes sense. Integral unscoped enumeration, don't know what that means. Pointer or pointer to memory version? To a Boolean? Like what? If something exists, or the pointer's pointing? Null pointer to pointer. Pointer to void pointer? Like how to make a pointer null? I don't know. Pointer to member? Like a pointer to a member function? Is that what we're calling these members? These are function pointer, it looks like. Pointer to no except function. Converts a pointer to a no except function. Yeah, I don't know what that means at all. They can fail. But yeah, we've seen that. Like numbers to strings or strings to numbers. Standard strings, at least. C style apparently always evaluates to 1 or greater than 1. True. And when converted to bool. Which is why we can use them with the logical AND operator in our conditions for asserts. If it can't, it will fail with a compiler error. Gotcha. So we're converting a character or a C-style string to this. Well, I mean, I guess it's a literal, but 14 is a character in ASCII, seems like. Well, there's 1 and there's 4. I don't know about 14. So, is it treating this whole thing as a whole character? I don't know how that's working exactly. Yeah, see, it is a string literal. That's what I thought. Okay. I guess I doesn't know what a string is by definition. I missed this. A pointer to a constant character. And it's constant because it's a literal. So this is like some temporary little object thing. And it points to that. So we're assigning him wherever this shit is, or whatever this shit is, to an integer. And it's an invalid conversion. Because there isn't a standard conversion, it'll fail. Or we can disallow them. Oh yeah, brace initialization for narrowing conversions. Yep. Data loss. Oh. Yep, because we lose the 0.5 here. It knows. Disallow for brace. Yep, so you can use specific features that remove or turn off and disallow other conversions for safety, at least in this case. Oh, so there might be multiple options. Function overload resolution and ambiguous matches. Now, if we're converting something to a function and then it doesn't know which one to do, prioritize one type over another or something, or the one that's closer to scope, or like more. Oh yeah. This is just some site that has a long list of all the rules and shit that are made by some guy. Okay. Yep. So 4. Yep. Versus a 64 might prioritize 8. Number of data bits that a data type uses is called width. Wider data type, more bits. If we want to modify a value like that, the point that we can create a value like that, but then we promote it, and then modify it, and then demote it, maybe? Meaning, what happens when we want to manipulate these smaller types? We're not going to if it's just a truth that the normal size of data for a given architecture is the most efficient for that architecture, then maybe it makes sense to disallow or prioritize converting smaller, more narrower data types, or narrower data widths, types with narrower width, or data types with narrower widths to be converted to those with a wider, more efficient width that's more close to the natural data width, and then convert it back down after manipulating. We promote it first, maybe. There are value preserving conversions and then unsafe probably. Well, yeah, because we're going from, and the point is a value or a numeric D motion might not be this. Well, probably isn't the same. Where if an int, a 4-byte 32-bit int can go up to this number, but a 16-bit can only go up to this number. Well, if we demote a 16 or a 32, so a 4-byte down to a 2-byte, well, can't hold as much info. We're narrowing, which might be an unsafe conversion under some cases, which is why brace detects that and prevents it. Makes sense. Yeah, because we're always having more space. You're always putting one box, the contents of one box, into a bigger box. You never have to worry about putting the contents of a bigger box into a smaller box, which may be okay if the contents of the bigger box do not exceed the volume of the smaller box. So we're promoting, so it's okay. Reduces redundancy. Oh, yeah. Instead of having to have different ones that work for your, so instead of having to have different types of prints, one to print strings that are characters of this size, one to print or manipulate integers of this size, another function to manipulate them this size. Instead, we can just say, hey, all these different values get converted to this guy, or we do stuff to it, and then either we keep it like that, or we bring it back. Yep. Short, character, different one for these. Yep. Int or double. Same code as behaves for the others. Yep. Integral and floating point. So smaller int to a bigger int, in terms of a smaller width to a bigger width, and a float to a double. Seems like I don't know any of the double types, but maybe there are others, or float types. Oh. Yep. Print double, double D, pass in a float, or pass in a double. And so it's okay. Oh, so it has to be, which should be the case, because it seems like as we go up, we go from an 8-bit one to a 16-bit one to a 32-bit one to a 64-bit one. In each case, when we're doubling, as long as we're actually doubling, meaning that if we have an unsigned int that has, instead of it being split, half signed, half unsigned, half positive, half negative, it's all positive. Well, if we double the size, the next one, the int, is this size, should be. So it can indeed fit that whole range in its positive side, and it can still hold stuff on the negative side. So it should be okay if it can hold the whole range of the type. Can you convert it to an int? It can hold the entire range, and if not, it can be converted to an unsigned int. Okay. I'm trying to understand the latter part of this. Yeah, meaning that they can always be converted to an unsigned int of greater. But sometimes they can be converted to a signed int if it's large enough, which it should be. Meaning we can pass it a variety of other types that are smaller than an int. So we have a short. So we could do print int with an int and print 2, but we can also pass it as short. There's no short literal, so we use the variable short s, 2 and 3. You can also do a, which is 1 byte because it is a character, it's a const character. And then we also have true, which is a boolean, which will go to 1. So all of these are smaller than an int, which is the parameter they're going to get converted to, or the data type that they're getting converted to. Meaning that there's a default that they get converted. So if there isn't a default, you have to statically do it or something. It sounds like these would be converted to an int because this is the int. But instead, maybe it's the case that they're being converted to another type, therefore they get promoted, but it isn't instantly known whether they get promoted to an int or an unsigned int. They just get converted to something bigger. Yeah, makes sense. Doesn't necessarily preserve whether they're signed or unsigned. Yeah, because in that case we're doing, we're not doing an unsigned here yet. But if we were then, well, actually it might even error. Boom. Warning. What if it's a smaller one? Oh wait, yeah, we don't do it on Sunday. We just do. Oh, it's actually okay here. Do some numeric promotion. Should be 16 okay as well because that's only 2 bytes. What if we say 32? Let's go. It feels good to be right. Issue here. And if we test earlier to see the unsigned issue, it's probably, is it? Yeah, because unsigned int, at least in this architecture, is 4 bytes per, which means we're converting a 4 byte thing to a 4 byte thing, but we're converting 4 bytes of positive numbers into 4 bytes of negative and positive numbers, and we can only fit 2 of the 4 bytes worth of information into the 2 bytes of positive information memory. Which means the compiler has an error and says, yo man, you're putting a box from one room into a smaller room that can't hold the box. But if you're putting it from a smaller room into a bigger room, you're okay. So, it's not necessarily the size, it also has the... So you have to have a bigger int than an unsigned int in order to fit an unsigned int. So like a 2-bit int could fit a 1 byte unsigned int. But a 4 byte unsigned int and a 4 byte int could probably maybe go to an unsigned int. I don't know what they're saying some here. Second, narrow or unsigned int may be promoted to larger. Cool. Oh, the point here is, well, we don't even need some. Oh, some is because they don't necessarily always fit. So, well, a larger one should be able to fit it though, because if it's larger, it should be at least 2 times larger. Like you're not going to find like a, maybe you do. Maybe you have a 4 byte unsigned int, and it will not fit within, it will fit within an 8 byte int signed, but it will not fit within a 6 byte int, if that's a thing. So, some may be promoted, meaning those that are half the size of the promoted value may be promoted to that promoted value. Width, size, something like that, type. Well, does not preserve the signedness. Not all widening are promotions. Character to short? I don't even know what a short is. Just less memory? Is it a 2 byte int? Character to short? Int to long? Conversions. Oh, so promotions are promotions are converting smaller types to larger types that are more efficient to process. That is the justification for needing such promotions. Promoting types to other types that are larger but are not more efficient, not the default most efficient version, are not promotions. We're promoting them from something that's actually efficient to something that is larger and less efficient, actually. Oh, yeah, so if we had two functions, and somehow we're converting, or we're using a function, maybe it prioritize. Oh, yeah, we're calling a function with a number, or with an argument, and the argument needs to be converted. Well, if we are converting a character, so a 1-byte int, into an int, that function might be prioritized. The one with the parameter of int might be prioritized over the same function name, the overloaded function, that has a type of long. Because now we're converting an inefficient data type, or data type with an inefficient width, or a less than optimal efficiency width, to another one that is actually too large that is now less than optimal, instead of converting it to the int. So the optimal one, the efficiency increasing conversion, will be favored. So the promotion can be favored over the conversion. Numeric promotion, numeric conversion. Gotcha. Promotion may be favored over the conversion. Makes sense. Okay. Yeah, especially for ambiguous matches, it seems like that's the main part here. If we aren't sure they're both within the same scope or something, and we're passing it into, yeah, it's not like we have two and this one's this and this one's this. This one's a fucking boolean and this one's a damn string, standard string. We can't convert them, maybe. Obviously, it chooses the one that's appropriate. But in the case where they're both valid, the compiler might say, hey, do the one that makes the most sense. Okay. And I found out now that I can double light tap and not make sound. I can't do one tap, but I can do tap, tap, drag, instead of tap, drag. This is quieter. Conversions of specific numeric types to wider numeric types that are processed more efficiently. Numeric conversions. They do not necessarily yield more efficiency. In fact, a D motion might even be more efficient. But I guess you probably wouldn't want to do that in general. Not the conversion. Integral type to another. Int to shorts. So these would be demotions, it seems like. They would look like they're demotions. Reducing the amount of memory something gets. Like a short to a char. Could be increasing into a long, into an unsigned int. Float to float, float to double, double to float. Oh, and long. I forget that there's a long, but then there's also a long double. Now these. Yo. My damn glasses. Just a dusty fucking room. A floating point to an integral type, so an int to a float. Or a float to an int, and an int to a float. Or an int to a floating point type. So an integral type to a floating point type. A floating point type to an integral type. Or an integral or floating point type to a bool. So, anything under 1 is probably converted to 0. Anything over 1 or 1 or over, probably converted to 1. True. Brace will disallow some of these, makes sense. Excuse me, we use copy initialization, that makes sense. Yeah. I understand that. Safe and unsafe. And brace is what uses the safe and unsafe knowledge. Many are unsafe. Are they only those that are decreasing the amount of memory towards something? Or resulting in lost value? So from a signed to an unsigned of the same memory means that, from an unsigned to a signed. It may be assigned to an unsigned, because if you have negative values, signed and unsigned might automatically be doing that. So maybe that's the why my compiler VS is automatically flagging it. So what is all over the damn... There's like dust on the monitor. It's not the damn booger flex. I know it's not that. There's no way. Unlike promotions, which are always safe, many are unsafe. At least one value cannot be converted. Yep. So signed in, unsigned, same shit. Both are unsafe, seems like. Value preserving are safe. All possible ones, so increased memory. Yep. Yep. Int n, and then long is getting the value of int n. Double d is getting it from short s. Oh, yeah, because a short is an int. So less memory int. And those values can all be represented by floating points. Oh, but a float to a double is narrowing for sure. Oh. Yep, so we're saying this integer n is converted to int along back, and this character converted to a character c. Ah. Can wrap my head around this. Oh, because here we have casted 3 to be a long. So this was a safe conversion, value preserving from an integer to a long, because it has been converted safely, in the same line, it can be converted back safely as well, compared to promoting, well, not promoting, but converting this integer to a long, and then later on initializing an integer with this long value. It's not the value that is special. It seems like it's the line that we've just converted it. So if the same line converts a value safely and converts it back, so from A to B safely, and converts from B back to A in the same line, it seems like it's okay. And then we're converting C, so character, to a double, instead of casting this return, this result of a double, to a character. And the reason is because in the same line, that we've seen that the value can safely be converted. And if it was safely converted, nothing was lost. And if it was safely converted one way in the line, that in the same line without the value being changed, it can be converted back. I wonder if that would be the case if we put in an operation in here. Not super sure about this part. A value converted. So if we're converting, if we have an integer, a bunch of integers that are added to floats, that are converted to floats, and those values are converted back to integers, maybe it's okay. Maybe it's okay. Okie dokie. I don't know why I was talking like that. I felt like I wanted to talk like this for a second, but I forgot I should do that. Oh, I don't know how I'm doing that. It's a weird way of talking. It's like Stitch from Lilo and Stitch. Wow, I haven't talked like that in probably since I watched that show. It maybe what? 8? It's been 17 years. Jeez. Okay, not sure how important this part is. Reinterpretive conversions, meaning that they've been converted and saved or something like this. Unsafe, where it may be different, but no data is lost. Meaning signed to an unsigned. Gotcha. So there are different types, yep. So it just depends on the value. Yeah. Because that's in the unsigned area of the integer. So we can convert it to an unsigned int. Cool. But if we have it in the unsigned part, or of the signed part, we convert it to an unsigned. Oof, no good. Yep. Reinterpretive conversions. Meaning that the value is reinterpreted in this new type. So the data's there. Why is the data there? It's the same amount of memory. Cool. Yep, the value is not preserved. Okay. Yep. Yep. Oh yeah, that's the word for it, modulo wrapped. I don't know how modulus stuff works. So still get wraparound. Yeah. How we do that? Whoops, I sat it on something I shouldn't have. Yeah, no, I don't. I've worn it. I was enabled, yo. Oh yeah, because they would be good. We would want to do like we want to access the last index of an array, we can do -1. The 0 is the first, and if we go back from 0, 1, we get -1. Which means we could store the index as a signed int, but maybe something else stores it as an unsigned int, so we convert between them. Hard to avoid, huh? Yeah, since it would only be a value change would be if you have a negative integer. Well, yeah, if it's in the array, then it wouldn't change anything. Because -5 would be the same as whatever's 5 from the maximum. What about an unsigned int? Would it be the same? -5 would be, -1 would be the max, the -5. Oh, so I guess the value would be the same for arrays, probably. That's fucking, this sound is annoying. There we go, that's better. A piece of wood keeps moving whenever the chair moves. Yep, so by default they're disabled. You keep them disabled, be careful of other types sometimes you don't want to convert the strings. Yep. And reinterpretive conversions format. Sounds good to me.